Chemical properties of glycerol molecule. Glycerol molecule contains two primary alcoholic groups and one secondary alcoholic group. However, both alcoholic groups are not equally reactive, though in many of the reactions it resembles alcohol and glycol. Reaction with electropositive metals like sodium. Monosodium glycerolate is readily obtained and the disodium glycerolate at higher temperatures. The secondary alcoholic group does not react. For example, reaction with sodium involves this as an intermediate step. On further addition of sodium metal, we obtain substitution reactions at this part and thus Na replaces OH groups here. And water is also formed as a side product. Now let us study about the reaction with hydrogen halides. Glycerol reacts with hydrogen chloride at 383 Kelvin to give both alpha and beta monochloro derivatives. Glycerol on addition of hydrochloric acid and at 383 Kelvin forms this as the product. Here, if you can see here, this OH group is being replaced by this chlorine atom. On further, we obtain glycerol alpha chlorohydrin and glycerol beta chlorohydrin. Third is about the phosphorus pentachloride forms glycerol trichloride. Hydrogen bromide and phosphorus tribromide reacts in the same way. Both react with PCI5 to form glycera alpha chlorohydrin. Phosphorus pentachloride is nothing but phosphorus at the center part and all these green balls resembles the chlorine atoms. Similarly, this also indicates PCI5 where the orange ball at the center resembles phosphorus and all the other brown balls here show iodine. With hydrogen iodide or phosphorus triiodide, allyl iodide is formed. An unstable triiodide is formed as an intermediate which loses iodine to give allyl iodide. Glycerol on addition of hydrogen iodide in the presence of Pi3 or I2 gives the product as allyl iodide, where the product shown here is the intermediate product. This is a dimensional structure for phosphorus tribromide. With excess of the reagent, allyl iodide further reacts, giving ultimately isopropyl iodide. The first step is the removal of this double bond by the addition of hydrogen iodide. The second step involves the removal of iodine atoms. Thus, hydrogen replaces iodine from both these places. Third step is known as propylene 3-step. On further addition of hydrogen iodide, we obtain CHI CH3 twice because the iodine replaces this double bond character by adding with hydrogen atom here. The first and the third step involves Markovnikov's rule where HI is added to the carbon-carbon double bond. The second step involves the beta elimination of iodine. The fifth chemical property deals about the cool mixture of concentrated sulfuric acid. With a well-cooled mixture of concentrated sulfuric acid and fuming nitric acid, nitroglycerin is formed. Glycerol is taken and 3 moles of nitric acid is added as shown here. These reactants are made to react under concentrated sulfuric acid. Thus the product obtained is known as nitroglycerin or glycerol trinitrate and 3 moles of water is formed as a byproduct. Similarly, with acetic acid, acetic anhydride or acetyl chloride mono, di or triacetates are formed depending upon the amount of reagent used. These are the respective structures for glycerol monoacetate, glycerol diacetate, glycerol triacetate, and this is the dimensional structure of acetic acid.